Enrico Fermi, legendary Italian physicist who made significant contributions to 20th century physics. But he devoted minimal attention to the Fermi Paradox, a concept he mentioned almost casually. The paradox revolves around the question of the whereabouts of extraterrestrial life in our vast galaxy. Our galaxy, the Milky Way, contains approximately 400 billion suns, most of which are now known to have planetary systems. Given the vast expanse of habitable space and the extensive time frame available for the development of advanced civilizations, the Fermi Paradox posits a fundamental question. Despite billions of years and countless worlds, we have yet to observe any evidence of extraterrestrial civilizations within the galaxy. The Fermi Paradox seeks to address the question of why there is a notable absence of civilizations in the Milky Way galaxy. One possible explanation for this paradox is that Earth is exceptionally unique in the galaxy. It possessed stable climatic and environmental conditions for a sufficiently extended period, allowing life to progress from simple cells to advanced civilizations. This requirement, when examined closely, presents a considerable challenge. In our understanding of the universe, we recognize its inherent violence, with frequent supernova explosions and celestial impacts, such as the well-known event that led to the extinction of the dinosaurs. Remarkably, despite these potential threats, there hasn't been an impact catastrophic enough to disrupt the uninterrupted chain of life on Earth over the course of 4 billion years. Therefore, it is plausible that while there may be billions of planets with potential features like liquid water and conducive environments for life, the conditions necessary for life to evolve into advanced civilizations might be exceedingly rare. It's possible that none of the planets within the Milky Way galaxy have remained stable enough for a significant duration to give rise to civilizations. This would suggest that the planet itself plays a crucial role, a concept known as the rare Earths hypothesis. Another explanation for the Fermi Paradox could be that civilizations have a cyclical existence, with periods of rise and fall. Given the immense timescales and vastness of the galaxy, it's possible that no two civilizations have ever coincided in time and space. Frank Drake suggested that civilizations may be like rare orchids that experience cycles of bloom and decline. They may bloom and then decline, with none of these cycles ever coinciding due to the enormous timescales involved. As a result, there may be remnants, relics, or traces of civilizations in the galaxy. However, we won't have a chance to confirm this until we explore the galaxy and possibly discover the ruins of these ancient civilizations. Another intriguing possibility is that the Fermi Paradox is not really a paradox at all. Intelligent civilizations may exist in our galaxy, and they may already be present in our solar system. It is only speculative to imagine what such a civilization might look like, but it could send nanomachines or probes throughout our solar system. It's conceivable that the technology of an extremely advanced alien species is so far beyond our comprehension and detection capabilities that we remain unaware of their existence. This possibility is entirely plausible. Another explanation could be the sheer vastness of the galaxy and the immense distances between stars. Consider the scenario of another civilization existing on the opposite side of our galaxy. Even if they possessed the most potent radio transmitters imaginable, the signals might dissipate over such vast distances, rendering them undetectable due to their extreme weakness. While it might be feasible to construct spacecraft capable of reaching nearby solar systems within a few light years, traveling across the entire galaxy presents insurmountable challenges. Another intriguing possibility is that there are numerous civilizations in the cosmos, but advanced societies deliberately opt to conceal their existence. This notion aligns with concepts like the dark forest hypothesis or the quarantine hypothesis. In this scenario, as civilizations progress technologically, they also advance intellectually and morally. They might choose, for what they perceive as good reasons, to remain concealed to avoid attracting attention. It's conceivable that, upon careful consideration, these civilizations believe it's inevitable that when there are multiple advanced societies in the universe, it is logical to stay silent and hidden. However, it's worth noting that, given human history, this behavior contradicts how we've acted as a species. We haven't made any concerted efforts to remain hidden thus far. We have actively transmitted radio signals into space and even included pulsar maps on our Voyager probes, indicating the location of our solar system in an effort to communicate our presence to potential extraterrestrial civilizations. Carl Sagan made a compelling argument that a civilization advanced enough to build interstellar spacecraft and communicate across vast cosmic distances might have transcended some of our primitive instincts. In this view, such a civilization could have overcome the tendencies to cause conflicts, wage wars, colonize other civilizations, or assert dominance. It's possible that with technological advancement comes a higher level of wisdom and ethical responsibility. It raises ethical questions about our right and wisdom to intervene or interact with other potential civilizations that may be out there. The concept of a great filter is a fascinating one within the context of explaining the Fermi Paradox. If such a filter exists in our future, it would suggest that civilizations within the Milky Way galaxy do emerge and progress to a point akin to our current stage of development. They would have achieved significant technological milestones, such as rocketry, nuclear power, and industrialization. However, somewhere in their future, there exists an insurmountable barrier that prevents them from becoming true spacefaring civilizations, precluding them from becoming multiplanetary species, and inhibiting their ability to travel between solar systems and colonize the galaxy. This idea raises profound questions about what that potential future filter might be. It could be related to environmental challenges, technological limitations, ethical considerations, or other factors that we may not yet fully understand. Exploring the Great Filter hypothesis is essential for gaining insights into the possibilities and constraints that could shape the fate of advanced civilizations in the cosmos. Why might there be a filter preventing our interplanetary and interstellar expansion? It may not hinge on technology or the laws of nature. Perhaps our knowledge and scientific prowess surpass our wisdom and political acumen. Once a civilization attains the capacity for self-destruction, through means like nuclear or biological weapons, it faces a precarious path. Our recent history bears instances where we narrowly averted catastrophe, like potential nuclear launches that were averted. Many unknown instances of near catastrophes likely exist. Consider the current challenge of climate change, where global unity remains elusive. This issue has the potential to regress our civilization. It might be akin to a natural law. The concept of the Great Filter attempts to explain the absence of evidence for extraterrestrial civilizations, a phenomenon known as the Great Silence. This lack of evidence may be due to the absence of other civilizations. The speculated reason, albeit uncertain, is rooted in biology. Examining Earth's life history, we observe its emergence 3.8 billion years ago. For roughly 3 billion years on Earth, complexity didn't advance beyond single-celled organisms. This phenomenon may have valid biological explanations. Consider the evolution of eukaryotic cells, which compose all multicellular life forms on our planet. These cells, vital for complex multicellular life, appear to have arisen only once, a widely accepted notion known as the fateful encounter hypothesis. This suggests an uncommon evolutionary event that set the stage for our existence. If the norm indeed entails a 4 billion year journey from single cells to civilization, it implies that very few planets in an average galaxy remain stable long enough for this process to unfold. It is hypothesized that there is only one civilization in the Milky Way galaxy, and that is us. We have a tremendous responsibility to preserve our existence, as Earth represents the only meaningful entity among the 400 billion suns. If we fail in this task, we risk destroying the meaning of life in the entire galaxy forever. Nevertheless, if this hypothesis turns out to be wrong, it not only relieves us of some of our collective responsibility, but is necessary for the progress of knowledge. Every scientist should be happy to be proven wrong, because it means an opportunity to learn and grow. No one should hesitate to propose hypotheses or educated guesses. Being wrong, even in a scenario as exciting as aliens landing and declaring their love, can be valuable. It would offer an opportunity to learn something profound about the universe, potentially challenging our assumptions about the prevalence of complex civilizations. There's an important lesson here. Embracing the pursuit of knowledge, even if it means being proven wrong, is a commendable endeavor. What are your thoughts on the subject? Share your thoughts in the comments. Thanks for watching.